Thanks a lot for having me, and no pressure, like 500 people in there, another 500 out there. Cool. And that works, right? So, we're going to talk a little bit about networking, just to get an idea. Who has been using Go 6 months or less? Oh, shit. A year or less? Okay, and the rest of you since the beginning. Okay, cool. The only interesting bit of information on that slide is probably that I'm a developer turned ops. I've been doing software for a few years now, and since 2014, essentially, I'm a gopher. I'm doing everything in Go. If you want to follow along, follow up, and given the new setup, I'm not actually going to type the stuff in there. It wouldn't have been possible with that mic anyways. So you would just trust me that the code that I show you actually execute. You can also grab the code and the commands I'm using from that URL here. So everything is there, everything's online. That's the reason why I can present now. All right, quick look at the agenda. Looks more than it really is. Unfortunately, because it's only half an hour, I don't really have the time to go into really deep detail. But if you are interested in, hit me up. I'm here until Monday. All right, the net package. The TLDR of that talk is essentially how forking awesome Go is, because it brings so many things already, typically in the standard library, and has awesome packages for everything else. So this is a kind of very high-level overview of the net package, not very useful, just a screenshot. There are things that you would expect, like HTTP, URL, RPC, mail, SMTP, and so on and so forth. And I thought about how can you actually, I tried to come up with a visualization that makes more sense if you're coming from the networking side. So who of you is comfortable with looking at that network layer stack? Pretty much everybody, right? Cool, awesome. So then we can just, I'm not going to explain what these things are, just one anecdotal thing. I think it was Vint Cerf who said, we won because we focused on the implementation, not on the documentation. Otherwise, we'd be looking at the OSI 7 layers. But yeah, that's where we are. So on the physical layer there, obviously .NET interface and hardware address. The thing here, I don't know if that pointer works. Yeah, that is pretty kick-ass. I had a look at that. Essentially allows you to dig into the Ethernet packages and so on. So if you're down there, IoT or whatever, and you really want to look at packages on that level, go and have a look at that. Networking layer, you have multiple things to represent IPv4 or 6 addresses, and then also masking and so on and so forth. And then Go packet, which is kind of like Google's Go packet, which is kind of like on that layer as well. Moving up the stack, transport layer, you have connection, IP connection, and then the application layer, pretty rich. And as you can see, so the black stuff is part of the standard lib, and the blue stuff is, not yet part of the standard lib. Yeah, so as I said already, things like HTTP, URL, and so on, all of that is built in. And then there are a few things which I wish that would be built in, and I believe, correct me if I'm wrong, who is here from the Go team who might be able to clarify that? I heard someone earlier. No? So, is there any good reason why WebSocket is not in the standard library? Okay, who of you wants to have WebSocket in the standard library? Give me a yay! That will probably be 1.15. All right. So I keep using Gorilla WebSocket. There are probably others as well. Yeah, we're going to have a look at that later. So I personally think this does not totally suck, but probably there are better ways to visualize it. But at least you get an idea on which layer certain packages work. If you have any question, feel free. So the first example we're going to have a look at is a curl, mini curl, really in a few lines of code. Essentially focusing on this part here, right? So we do a HTTP GET here with the URL provided by the argument, and then using HTTP util dump response to just have a look at the result. And this, I mean, obviously the real protocol has a few more features, but this already kind of like shows you the power of the actual build in the standard lib stuff. Yeah, okay, so second part here that actually, pulls out the stuff from the body, and then in this case, the example used here essentially allows you to specify the amount of like the payload in bytes that you actually want to display then, just to show you how you can, read only partial responses there. Next example would be an app server, so something that has an HTTP API and responds with hopefully something useful. So in this case, actually, that would already be the FOSDEM Go dev room with 3,000 if they would fit in. So in this case, you're essentially just using the standard vanilla HTTP handle func and provide the path. So whenever I do a curl or HTTP on, it's running on 9876, the port /about, then I would expect to get back this this struct in JSON, encoded in JSON. And believe me, if I would have my own laptop, I would now do curl, and you would see that JSON there. Again, pretty straightforward. The only thing, and I'm going to talk about that a little bit later around the best practices, is that this here is a little bit too convenient, a little bit too, like the defaults could be a little bit better. Again, if you disagree with anything here, please tell me later. This is essentially what I'm kind of criticizing. Like if you're doing that, right, you're probably doing something wrong. What you really should be doing, and someone thankfully put together a gist, so I didn't have to do that. And that's the kind of like the gist of the whole, the gist of the gist, the real thing here. So you really want to set timeouts here. You really you can have a handler here for tracing the request in here, an error logger, and so on and so forth. So really, like, it's there, so please use it. It is in the standard library. Please use it. Do use timeouts. Do use retries. The next example that I had is around a very, very like silly, stupid, simple RPC client server that essentially, in this case, it's really just a fixed call. So have a look at the server here. Essentially is listening again on a certain port, in our case 1, 2, 3, 4, and then just waits for incoming connection, and then executes on the server side a certain method here. And the method is essentially just a multiplication, so it takes 2 input parameters and then multiplies them and gives that back. And sorry, that was the client. Oops, that was the client. On the server side, effectively just sits there and waits until client connects, an RPC client connects, and calls a certain function. That is great. I'm kind of like on the fence here with the RPC built-in standard library. It's good enough, but there are, I'm going to come back to that in a moment, better options or more flexible, more powerful options. Any questions so far? Okay. Second level programming. I love that. I didn't put the link to the video there. I think it was LinuxCon Australia or something like that. A guy giving a talk about essentially IPv6, and that really, like, took a snap of that. That really fascinated me. So if you compare IPv4 with IPv6, just a summary here, just to get everyone on the same page, this one here is the real thing, right? So if you assign every IP address essentially some weight, it would be 75 milligrams for all the IPv4 addresses that we have, and roughly the mass of the Earth that IPv6 has, which means that's quite a lot of addresses, right? So a lot of things are possible and will change. But unfortunately, which I'm still pointing out there, it's a bit like the year of Linux desktop, right? It's every year it will happen, and yet still 2018 we're still using IPv4 like hell. Anyways, quick reminder or recap regarding ports. Everyone familiar with ports and those different ranges here, privileged, well-known ports, IANA registered ones and ephemeral ones? Yeah. Okay, cool. And for the next slide, essentially just we more or less distinguish between connection-oriented TCP, for example, that's used by, thank you, by HTTP and many, many others, and connectionless or broadcast types like UDP, which is still used by DNS, but I would argue that many, many layer 4 protocols nowadays actually use TCP. So in this case, what you would see, if I would type it in here, would essentially be a HTTP GET using the low-level functionality that the standard library provides. So we are actually, the main things here, we first resolve the address, then we use net.al TCP to get there, actually send the head request, so not the GET, but the head, sorry, head for HTTP 1.0, and then the rest is more or less the same as we have seen earlier on, getting the response back and parsing that and printing it out. So obviously for HTTP you probably don't want that, but you can use that pattern for other layer 4 protocols to just build your own client or whatever using these low-level primitives. Can be very useful. So I'm halfway through the time and my talk. That's awesome. So let's see. Timeout and retries. So who has not used either timeouts or retries in their production code? Everyone? You liars. Come on. I'm raising my hand. I am guilty. So it is still very much the case, and given cloud, public cloud, and this and that either the network between you and your favorite cloud provider, or within the cloud provider, or any third-party services that you might be calling out to, which is increasingly so the case, this is not reliable. So you will run into things that it just times out, and if your code is not aware of that, well, you're probably gonna debug, and then you probably should use Delph. And it's like it's minimal overhead. It's not like that you need to invest a lot of time and pretty much natively support it within the standard library. So please do use timeouts, do use retries for that. And to me, I nowadays would say this is really a hard requirement for production level or production quality software. If you don't do that, the code review should point that out. There are 3 resources I found, reviewed many, but these 3, I cut it down to these 3 that I personally think really are very, very helpful. If any one of you is in the audience or is looking live, hello, thank you for putting that together. That's very, very helpful. Security. Who doesn't like security? I must say I'm pretty, again, very, very impressed when I had a look first when I came to Go, to what extent Go really provides security related features. We know crypto, and there are many, many things that you can use out of the box or packages that are available. And essentially, again, pretty much like with the timeouts and retries, if you don't leverage that, if you don't use TLS, many other things around there, then don't come and complain. It's not Go's fault. DNS, that is probably my most favorite topic, and maybe either now or over a beer, someone can explain to me. My hunch would be it's probably due to portability reasons, but why the fork does Go have 2 options here? Why does it have the pure Go resolver and the CGO-based resolver there? I have no idea. If you know the answer, please hit me up or yell at me now. I'm more than happy to learn. Essentially what it means, so a very, very simple example, just to grab something, FQDN, and look it up. And luckily I put the result here as well. So if I do that on my local laptop with the Go debug netDNS set to CGO, I actually can resolve, I don't know if you see it here, that's the name of my .local domain on my machine. Well, not my machine, but the one that doesn't work. And I would actually get an IP address here. So the DNS lookup here would work. If I do the same with netDNS Go, it panics, right? I'm not judging that fact. I'm just really, if you forget everything else, but please remember that, and it will probably save you a few gray hairs or a couple of hours of your life getting back if you're running into that issue in whatever setup. It certainly did for me. DNS, so my favorite topic is gone. Coming back to RPC, getting more and more interesting, and thank you. You know, the REST hype, if you wish, seeing a little bit of competition here from RPC. So, as I said, it's perfectly okay, I think, to use what the standard library offers you in terms of RPC. If that doesn't help you, or if you're limited by that, here you have two great choices. gRPC, originally created by Google, and I believe it's pretty much the same that they're using internally. It's now a CNCF project, the Cloud Native Computing Foundation project. It's very fast and powerful. I guess the only reason that Twitch came up with twerp here is that it requires HTTP 2. So Twitch apparently was initially a gRPC user, and then said, well, we'd really like to use HTTP 1.1, and we would like to have a non-binary JSON representation, which makes it easier to debug. And that's why they came up with twerp. Pretty new, couple of weeks or so old, so I didn't really have a chance to go deep into that, so I can't really answer questions around it. If anyone from Twitch or who has used that already is here, I'd love to talk with you. And then there are a bunch of other non-standard libraries or packages that I encourage you to check out. We already had the WebSocket there and the Apex Gateway. DNSFS is a pretty cool hack implementing a file system on DNS. That's pretty nice. We had Google Go packet inspection, and for low-level stuff, Ethernet packets, this one here. So depending on your use case and the situation you're in, you find yourself in, you probably want to have a look at, before you write it yourself, maybe have a look at those things. They're pretty kick-ass. Web frameworks. This is probably my second favorite slide on that deck. And I could, if I'd be in my laptop, I could actually GoPresent still doesn't support videos. That's a feature request, right? We should really have videos in GoPresent. It does, but not, which one? Oh, I love you, Francesca. So this is an animation where this guy goes like into that, time sink. So if you come from another environment, if you're, Ruby on Rails or whatever, and you go like, wow, Go doesn't have, or what are the frameworks? Well, someone put together the top 6, and actually that's a very nice, very nicely done. So there are, of course there are, people, especially coming from different languages, put together these, and as you can tell from the stars and forks and whatnot, pretty popular. But I also encourage you to read that one here, because it is quite often true. You don't necessarily need stuff like that. A little bit on the fence. Probably I'm doing the wrong kind of things to actually depend on that, but it's there if you want it. Quick recap or summary of best practices writing networked applications. In general, there is this old, the fallacies of distributed computing. I gave a GopherCon talk last year about that. And it's still very valid and probably even more so. So be aware of the fallacies there. There is a very nice context package. I didn't really go into great detail early on, so do use the context package wisely. And again, reminder, do use timeouts, do use retries. And obviously the 3 T's. Test, test, test. In terms of, and I'm coming from the Kubernetes land, so this kind of like health checking, probing is kind of like, built in. There are 2 kind of philosophies there, or 2 ways to approach that. You can either subscribe to the idea that you push the instrumentation to the developer, so it's you actually writing instrument the code, pprof, there's Go metrics, whatever, or you kind of like outsource that to a service mesh like Istio or Conduit. They have sidecars, and they essentially do that stuff for you. Whatever you do, please do it. Any kind of metrics, either the developer themselves or some other thing that sits on the sides and does it for you. It's really useful, really helpful. And with that, I'm already on the last slide and happy to have a discussion. A number of things that are very, very useful if you're not that deep into networking with Go. I based many of the examples on this wonderful online available book, Network Programming with Go by Jan. And then there are a couple of other blog posts and so on that I really, depending on what you're into, gRPC or whatever level, would encourage you to read. And with that, I'm open for questions. Thank you.
Before we do the Q&A, quick reminder, if you're in between my face and the camera, you're on the video. We're going to do the Q&A, and afterwards, I'm going to have to kick every single person that is standing up out of the room. It's not my rules. So please make sure that there's no free seats anywhere. I'll remove all my stuff from my seat, so if someone wants to use my seat, I will be just chilling here, so please try to do that. And now Q&A. Any questions?
Yes, please.
For the DNS problem, the reason there are two name resolution systems is precisely because it's not DNS. DNS is just one protocol to do name resolution, but you have other, such as MDNS, which is not DNS, for the name in .local. Also, you have the local file, or etc.
Right.
Like that. And you have a policy built into the gRPC to choose with CNSS switch at once, etc.
Right.
It's very hard for any new language to completely emulate all this style, this policy, the different name resolution system.
Okay.
That's why Go use first to the
Quick comment, Q&A. So we're going to accept only questions, especially because we cannot hear you. So if you have a question, please go for it. Thank you.
Okay, just to quickly recap what you said, it's essentially the DNS stuff that I mentioned there, essentially more or less to be more flexible to accommodate a range of different naming resolution systems. Okay, thanks. I'm going to build that in. Any other questions? That seems not the case. You're just scratching yourself, right? Okay, cool. Okay. Yeah. The question was if I have any recommendations for libraries like PCAP, and yes, the answer is it is in that slide. It was the GoPack. Yeah, thank you. So have a look at that, and I tried it out. It's pretty kick-ass. Yeah. Okay. Thank you. Thank you.